Hey everybody, my name is Alex with Hake Hardware, and in this video we are going to go over how to get a farmer cluster set up. If you have already set up a non-cluster farmer, this is a little bit different because the farmer is broken down into 4 different parts. We have the controller, which is kind of like the brains of the operation. We have the cache, which stores the piece cache for plotting. We have the plotter, which does the plotting, and we have the farmer, which does the farming. And the plotter also does the replotting, just a side note. And you can run everything on a single host. And in this video, that's actually what we're going to do. But the more common method is like, let's say I have a farmer, I have a specific host where it has like a disk array connected to it, and I have like 20 disks, and it's just a farmer. There's no GPUs hooked up to it. And then I have another computer, maybe my gaming computer. I have a GPU on it. What I can do with a cluster is I can set up my gaming computer to plot to my other computer, my farmer, whereas you can't really do that when you're not running a cluster. Or if you have like 3 or 4 different computers with GPUs, then all those can be connected to the same cluster, and all of those can help plot that single farmer. So it allows you to scale your farms and share resources a little bit better. The example that I'm doing in here is basically like the smallest example of a cluster, but keep in mind like every component, the controller, the cache, the plotter, the farmer can be duplicated either for redundancy, so if you have extra controllers, extra cache, or to increase plotting speed or farming size. So more plotters, you can increase your plotting speed. More farmers, you're increasing your farm size. So it's really a good way to scale out your farms. I think I will do a advanced cluster guide. I kind of did one before, but I'm redoing all my guides now that mainnet's coming up. So I'm thinking about redoing that, and hopefully I'll have something here soon in case you're interested in kind of scaling out a little bit more. And it's important to note that when you're running a cluster, you now need to have NATs. So just some prerequisites, you should have a node running already based on the guides, and you should have NATs running either as a service or in Docker. So if you're following the CLI guide, everything is being installed as a service, but if you're just kind of bouncing around, you might have installed NATs as a Docker container or NATs as a service. Either one should work fine. And then there are some plotting requirements for GPUs, like this guide is specifically for Ubuntu. You're going to need version 550 or higher. I recommend just getting 560. But theoretically 550 or higher should work. Everything that I do is in like Ubuntu server, so I'm starting from scratch and I just install the 560 drivers, but you may have like Ubuntu desktop and have the 550 drivers already. You shouldn't need to upgrade, but I've seen some people have better success on the 560s, but I haven't verified that myself. Okay, basically what we're going to do, and another interesting note is that the cluster farmer, it uses the same executable as when you're not running a farmer, but you just specify the specific component. You specify that it's a cluster and you specify the specific component, and you're going to have 4 different scripts that we're going to basically do. So the first step is to make, actually the first step is wrong. Let me change it here. Farmer cluster. Get to see me do it live. So we're actually going to put everything in the cluster directory. So when I did the farmer guide, the non-cluster, everything went in the farmer folder, but for the cluster, everything is going to go in the cluster folder. So that's the first thing we're going to do. Let me jump over to the terminal and we're going to basically take it from there. So let's do make dir -p. You can do -p, but you should already have an Autonomys folder. And then I'm going to do cluster. And then this basically just goes over which version to download. Let me actually bring you back. Which version to download. So let's go to the subspace releases. We can see that November 1st is the latest version. And we'll scroll down here. If you want to get the node, we're doing farmers, but just keep in mind you might have to click show assets depending on which you're looking for. And we're going to do Skylake. It kind of explains it here. And I explained it in the Node and Farmer tutorials and guides as well. But basically, Skylake is going to be like the more recent processors from like basically 2015 to newer. And then 2009 to 2015, you're going to look for like V2. And then older than that, you have to compile it yourself. It's outside the scope of this guide. So for me, I'm going to look for Farmer, Ubuntu, x86, Skylake, Taurus. So I'm going to copy this. And then let's jump back to the terminal here. And we're going to just use wget-p to specify where we want to download it to. And I'll do the // so my home directory, Autonomous cluster. That's where I'm going to want to do it. So I'll paste in that link. And if I cd into that, we can see we have a binary here. The next thing we're going to want to do is make it executable. And some people rename this file, and to rename it, you would just do like move subs, and then you could just name it like subspace farmer. But I like to keep it the full name. That way I know exactly which version it is. Because a lot of times I'm running multiple farmers on different computers, and I forget which ones have been upgraded and which ones haven't. And I'm sure I could do like dash help and get the version, but personal preference. If you want to change it, just keep in mind you'll need to change it for the rest of the commands here. Okay, so typically, like in the node guide, I go over tmux and setting up scripts at the end as an option. But for clusters, I really think it's important to use tmux, and it's really important to use scripts because you're running like 5 total, including the node. You have the node, the controller, the cache, the plotter, the farmer. It just gets really tedious to keep track of all this stuff. And tmux, which is a session manager, a window manager basically, you can run everything in sort of like the same window. It's really neat. You can make labels. And honestly, the node we don't have running like that. We don't have running in the same window or session as what we're going to do the cluster, but you could even add the node to that too and make everything kind of in one. So if you haven't used tmux before, you're going to see it a little bit. It's super easy to use, and I'll walk you through each of the different things that we're going to need to do. But the first thing we're going to need to do is set up our folder structure. So we do need a folder for the controller, and we are going to need a folder for the cache. So the cache, we'll get to that when we deploy it, but we're going to start with the controller. The controller is going to be the first thing that we deploy here, and it basically is just going to sit and wait for things to be connected to it. And we already have nats running, so keep that in mind. If I do sudo systemctl status nats, it is running and it's waiting for connection. So we're live, we're ready to go. Let's create this folder. Make dir, we'll do autonomous cluster controller, and it's just going to store like some identity stuff in there. And then we're going to create the script right off the bat. So we'll do nano autonomous cluster, and we're going to put all of our scripts alongside our executable. So it's actually going to be in the current directory. I didn't need to do the full directory path here, but I'm just doing it to be like very obvious what I'm doing. And then we'll call it the cluster controller.sh. And I'm just going to paste in the script here. But I have some variables set up. So the node IP, I'm running the node on the same computer as I'm running the cluster. So I'm using localhost. If your node is on a different computer, you're going to have to use the IP address of the node, the internal IP address of the computer, the host running the node. NATS IP, same thing. I'm running it locally, but if you have NATS running on a different computer that you're using, you're going to have to use the full IP for the NATS. I'm using the default port for the node, and I've specified the default port for NATS, but if you want, you can change it here. And then I have the controller directory, that one that we just created. The $home is just a variable for the home directory, autonomous cluster, and controller. And this is the executable. So if you update to a new version, you're going to have to download that new binary, and then you're going to have to specify it. And this is actually wrong. I need to fix the guide. It should be // fix that real quick. I thought I fixed all those. Okay, and then we're just specifying the base path. That's going to be where the controller goes, and we're specifying the node RPC URL. That's the node IP plus the node port, and then of course we have NAT server up here, and we can do and this is what I mentioned earlier. We're just specifying that it's a cluster, and then we're also specifying the component type, which is controller. Otherwise, it's using the same executable. And then we'll do Control X, Y, and then enter to save. And now we're going to make this executable. So chmod plus X. I'm not going to do the full path anymore. I'll just do cluster controller. And then we're going to create a session for tmux that's going to hold all of our cluster stuff. So I want to make sure that I'm in the autonomous cluster folder, and then we'll do tmux new -s for new session, and then we're just going to call it cluster. So this is a name that we're giving our session. And the first thing we're going to do is rename this. So at the bottom here, you can see it's called bash, 0 bash. We want to give it a name. So we're in the cluster session, and we have different windows. So our first window is called bash, but we're going to do Control B and then comma, and then we're just going to delete bash, and I'm going to put cluster controller and then hit enter. So now we've named our window cluster controller for our cluster session. And we can just start the service at this point. So /cluster controller.sh, and we can see the cluster get kicked off here, and it is getting started. And it's really not going to do much until we start attaching other components to the cluster. So let's move into the cache, and I'll just come back to the guide here. So we are at launching the cache, and the cache stores the piece cache, which is used for plotting. And if you have like a plotter on a different computer, you typically want to pair the plotter with a cache, because what happens is the plotter needs to get data from the cache, and then the plotter pushes data to the farmer, the plots that it creates. So there's a lot of data transfer between the cache and the plotter and the farmer. So typically you only want to have that last leg between the plotter and the farmer, because that's where people usually have the components separated. Is they might have a dedicated plotter and they might have a dedicated farmer, and then the cache will live on the plotter, and then it'll push data to the farmer. So that way you're not getting like a ton of network usage. You can cut down on it that way. And the cache, we kind of touched on it earlier, but the cache, it's basically storing blockchain history. So the ideal cache size is just slightly larger than however big the blockchain history is. In the last testnet 3H, I think it was around like 140 gigabytes or gigabytes, or maybe it was 120, something like that. I just did 200 gigabytes because I knew that was going to be more. And it starts out small and it grows, right? The blockchain history is growing. So let's say it starts out at 10, 20 gigabytes, and then you set it at 22, and then it grows to 25, and then you have to expand it to 30. It's best to just, if you can dedicate like 100 gigabytes or 200 gigabytes, to like just go as big as you can. And if it's too small, it's not the end of the world. What happens is when the plotter's trying to plot and it needs a new piece from the piece cache, if there's a miss, there's like that piece is missing, it has the piece cache, or the cache then has to download the missing piece. So that can slow down plotting if you have like a RTX 4090, or you just have like really fast plotters, and it might just be waiting on those pieces to get downloaded too often and slow down. Now I know the team is trying to get it to the point where like it's not that big of a deal, but practically speaking, I've seen plotting be slower when the piece cache is not at least the size of the blockchain history. So again, you're going to need to look up what the blockchain history size is at the time that you're going through this, because right now, Taurus testnet, it's like really small. I think it's like a couple gigabytes, so it's not a big deal. And I'm going to set it as 200 for this guide, so it's going to be way more than I need, and it's going to download really fast. So anyways, I've been talking about the piece cache for a while. Let's just move into getting it deployed. And the first thing we're going to do is actually create a new window. So right now we're in the cluster controller window. Let me actually move back to Termius. We're in the cluster controller window, and we're going to do Control B and then C, like create, to create a new window. And you can see we've got a new prompt here, and now it's called bash again. And you can see there's a 1. So now we're on screen 1. We got screen 0 and 1. Computer nerds, they like to start with 0. So we're in window 1. And then we're going to do Control B, comma, to rename it. And we'll call it a cluster cache, and then just hit enter. So now we have controller and cache, and now we need to create the cache directory. So for the purpose of this guide, I'm going to create the cache directory in my home folder because I have a 1 terabyte drive for my operating system, and I know that I have 200 gigabytes that I can set aside for the cache. If you have like another SSD that you connected and you've mounted it, you can use that mount point for the cache. It doesn't have to be on the home folder. That's just how I'm doing it for the purposes of this video. So the cache folder can be anywhere you have enough space to store the cache. And again, you don't have to make it bigger than the blockchain history size. That's just the best way to do it so you plot quickly. So I'm actually going to do make dir autonomous cluster. Then I'm just going to create that cache drive. And then we're going to create the script. So nano autonomous cluster cluster cache.sh. And I'm just going to paste in. This one's a little bit smaller. On each of these, we're going to be specifying the NAT IP. And again, my NAT's service is running locally, so I'm just going to specify localhost. This is my cache path. This should be updated to wherever you want to store your cache. Mine's in the home directory, autonomous cluster cache. And actually, I'm going to do 100 gigabytes for this. So you can set the size there. And I typically do gigabytes. I find that to be the easiest, but you could do gigabytes, I think, or just a G. Not sure like all the available options, but I just tried gigabytes. And then we've got the cluster specified. We have the NAT's IP, and then this is the cache, so that's the component, and the cache path and cache size is specified in the command. So I'm going to do Control X, then Y to save, then enter. And we need to make the script executable, so chmod plus X cluster cache. And now we can just execute that script. Oops, but I need to spell it right. And we can see created cache. And we can see max number of elements. It's, suspiciously close to like the megabytes for my cache size. And this is the cache ID. And what's even cooler, okay, so we have 2 windows here. We can switch between those windows with, so if you haven't noticed, Control B is kind of like it tells tmux that we're about to give it a command. That way you don't accidentally start like typing on your keyboard and executing commands. So to switch between windows, we can use P and N, so previous and next. So previous would go backwards, and you can see there's a little asterisk here. This means that's the current one that's selected. So if I press P, it'll go backwards. I mean, I only have 2, so if I press next, it'll go backwards, technically 2. But just to show you, I'll do Control B, and then I'll do N. And you can see now I'm back to the asterisk is by the controller. So remember P for previous, N for next. And you can see that the new cache was discovered when I added it, and it's immediately beginning the piece cache sync. So we'll do Control B, N to go to the next. And now we can actually create a new window for the plotter. So we'll do Control B, C for create, and then we'll do Control B, comma, to rename. And I will do cluster plotter. And I don't know if I explicitly mentioned it, but when I'm saying Control B, like hold down Control, and while you're holding Control, press B. It's not like Control, let go, then B, let go. And then when I say, so like, let me actually just go over to the guide. I want to make sure this is right because I know some people have mentioned in the past that it's confusing. So it's Control plus B at one time, then you release it, and then you're going to press C. So when I do it like this is like all together, then you let go, then comma. So if I wanted you to do comma at the same time as Control plus B, it would be like in the same highlighted section. All right, back to the terminal. All right, we're at the plotter, and we already created our window, and we want to create our service. So instead of doing the full, you get the picture with the full paths. I don't need to do that anymore. Everything is being created in the cluster directory. So I'm going to do nano cluster plotter.sh, and we're going to paste in the cluster command. And this one's super easy because it's just a plotter. We have the NATS IP like we always do, which is localhost for me. We're specifying it's a cluster and then it's a plotter. And then we can do Control X, Y, and then enter. We're going to make this executable, chmod plus X cluster plotter.sh. And then we are going to launch the cluster plotter. Now there's no farm connected, so nothing's going to start plotting. So we'll do dot slash cluster plotter. And we can see, so NATS is always the first thing that happens. It gets connected. We can see that it says queue to devices 0. That's the device. Remember when I said, it starts at 0? So my first GPU is actually GPU 0. If you see using queue to GPUs, that means it's detected your GPU. And you can see that CPU plotting was disabled due to the faster plotting with GPU. So if you see that, that means your GPU is enabled for plotting. All right, that's it for the plotter. Plotter's super easy. Now to the farmer. So we'll do, again, Control B, then C to create a new window. We'll do Control B, comma, and then we'll delete bash and we'll name it cluster farmer. And what I typically do, okay, so before I get too deep into this, if you're coming from, and I'll bring you back to the guide real quick. If you're coming from a non-cluster setup, let's say you've plotted your disks already, and you're moving from non-cluster to cluster, because the piece cache is typically stored on the farming disks when you're running a non-cluster setup, if you try to just mimic your commands from a non-cluster setup, you're not going to have enough disk space because it's going to try and use the full amount you specify, whereas you still have the piece cache from previously on your disks. So I can't show it here because I don't have that situation, but you would need to go to wherever your disks are, your farmer disks, and delete the piece cache .bin from it. Leave everything else, just one file, delete the piece cache, and then you should be able to run your farmer commands, almost copy paste of like what you used to do for non-cluster. So if you are switching from non-cluster to cluster and you get an error that you're out of disk space and you know that you put in the right size, it's likely that you have a piece cache.bin in your farmer directory in the disks, like the disk that you are farming. You need to go in there and delete that piece cache bin. I know it's kind of confusing. If you still need help, join my Discord and ask in there, and I'll help you out. Okay, so one good way I found to just make sure that you're getting the right size, you're using the maximum amount of space, is I do df -- block size equals G. And this gives me the GB bytes basically that are available. And I like to specify it in GB bytes because it's like it's very accurate way of specifying your disks. So these are my two farms that I set up based on the farm preparation guide. And I want to copy these. You don't have to, but I always just like Control Shift C and copy these, and I paste them in a notepad because I'm going to need to copy and paste them into my farmer script. And we can create our farmer script, nano cluster farmer.sh. This one's a little bit bigger. because there's a lot going on here. I'm going to paste this in here, and we'll go from the top. So we already know NAT's IP. We do that every single time. You need a reward address, and that's how you get rewarded from your farmer. So I'm going to delete that, and then I'm going to try and remember. Shoot, I don't know if I have my reward address. Actually, let me bring up. I do have my reward address because I'm farming on another computer. So let me grab my reward address. I do need it to proceed, so give me 1 second. Boom. Okay. Got a bunch of these. Let's get this going here. Okay. Paste that in there. We'll need that in order to... Oh my gosh, I'm not showing you my screen. Okay. Glad that I looked. All right, so you already are familiar with NAT's IP. You're already familiar with localhost because I'm running NATs on my current host. Reward address, I just pasted that in there. All right, farm paths. So you can have a lot of disks, right? You might have 10, you might have 20, you might have one. If you have one, you can actually just do like Control K and delete that one out of there. And if you have more than one, then you're going to want to make Control Shift C to copy that, press enter, paste that in there, and give it some space. I thought that I would need commas between these, but I did not need commas. This is a new concept for me. It's just a new line, and apparently that's enough. All right, so I have my copied information, and I'm just going to copy the path to my drive. And I'm going to delete this and paste in my path. And then I know for that path, it's 14304. 14304. Then I'm going to put in GB bytes. And then I'm going to paste in my next farm. Paste. And then weirdly enough, these are two different manufacturing drives, and this one's 14303. It's just one gigabyte different. All right, and then we have our full command here with the imported nats, the imported reward address, and then we have our little loop down here that specifies our farm paths. And then we execute the command at the end here. So it's a little bit complicated. Hopefully I did this right. But we'll just do Control X, Y, and then enter. And if I'm not mistaken, we can run this. Cluster farmer. What's happening here? Oh, you know what? chmod plus X cluster farmer. Let's see if this works. Okay, NAT's connected. Downloading segment headers. It usually does take a little bit of time here. I'm not worried. Not worried at all. It's going to happen. There we go. All right. It's pretty big disks. They're like 14 terabytes each. So yeah, 15.4 terabytes, 14 bytes. And you can see it started plotting sectors. Now it's not really going to start picking up pace plotting until your piece cache is synced. So if you remember, we can do Control B, then N. I need to actually select the window here, Control B, and then N. Oh, and we can see we're still doing our piece cache sync, but we can see our two farms were discovered and initialized. So we should see the piece cache here. Yep, I'm almost done. So once I get to 100%, that's when the plotting is really going to start kicking in. And if we go to Control B, then next, Control B, then next, you can see on our plotter, we had some plot sector requests come in. So we've got two plot sector requests, and we have two logs here on our farmer saying that we're plotting those sectors. So we're good to go. We have a cluster running. Now, if you want, you could add, like, let's say you have another computer with just a bunch of SSDs. You can actually just run just the farmer, only the farmer and nothing else, and connect it to NATs, and it will automatically start getting plotted to by your other plotters. Or let's say you have another plotter that you want to use to start plotting this farm. You would just run just the plotter part and connect it to NATs, and it would automatically start helping plot this farm. So you can see why this is pretty cool. And like I said, if you're going to run like a dedicated plotter on a different computer, you're going to want to put the cache and the controller on that other computer typically, or at least the cache, not necessarily the controller, but this is getting into like advanced clusters, which I will do a guide on for sure, because there's a lot more that goes into clusters just to make sure, because the biggest bottleneck people are running into is that their network bandwidth isn't enough. Like for a 4090, you need like 2.5 G internet. If you're doing a more than that, you really need like a 10G internet connection. So as much as you can do to reduce the network traffic is really going to help in the long run. So hopefully you got everything set up. If you ran into any issues, feel free to join my Discord or leave a comment on this video. If it was helpful, please feel free to leave a like, and I'll see you in the next one.